Thanks for attending this talk. My name is Sam, and I'm a second-year PhD student at Harvard University. So today my talk will be on pitching a new way to think about and evaluate deep recommendation inference. Now, whether you know it or not, recommendation is everywhere in our lives. Whether it's YouTube, Facebook, Amazon, or other internet service companies, recommendation systems are used to provide us with personalized experiences. In order to efficiently analyze the bottlenecks of recommendation systems, we propose using a cross-stack approach. First, we have the algorithms. Depending on the application, recommendation algorithms used will vary. Next, we have the software. Since these models are deep learning based, the model implementations themselves are often based on popular deep learning frameworks. Lastly, we have the hardware platforms. Leveraging heterogeneous hardware in the form of CPUs, GPUs, and accelerators is essential from both efficiency and infrastructure standpoints. So the key question that we want to answer for this work is, what are the bottlenecks of each layer and how do they affect one another? In order to answer this question, we first evaluated 8 industry representative recommendation algorithms on different systems platforms and use cases. We analyzed the performance trends of these models on server-class Broadwell and Cascade Lake machines, and also 1080 Ti and T4 GPUs. From here, we concluded that the optimal hardware and attainable acceleration vary based on model architecture and input use case. Second, we conducted an algorithmic and software-level characterization of these models. We broke down the operator usage of each model across different use cases, uncovering affinities between certain operators and hardware platforms. Last but not least, we investigated the effects of different microarchitectural structures and explore how they can affect model performance. If there's anything that you need to remember from this talk, it's this. To deploy recommendation efficiently, you have to understand your use case. What application do you want to run? What model does that require? And at what scale do you want to run your model? Second, to improve recommendation, we can find opportunities at both software and hardware levels by looking at operator and microarchitectural characterization. If you're interested in this work, I recommend you take a look at the paper for detailed results and characterization insights. Most importantly, please check out the open source DeepRexis repository. The model implementations themselves and experiment scripts are all published at the GitHub link. Thanks for listening. I'd be more than happy to answer any questions.